Part C, find the probability that the travel time is between 52 and 54 minutes. So I'm going to open the normal calculator in StatCrunch, and here in StatCrunch you can have any worksheet open and go to Stat Calculators and then hover over the normal button and click, and the normal calculator should pop up on your screen. By default, we will see the standard normal distribution with a mean of 0 and standard deviation of 1. We need to set that up according to our situation. So here the mean is 53 minutes and the standard deviation is 4 minutes. So we're going to be using that for all of the remaining parts of the question. To answer the question, what's the probability of a driving time between 52 and 54 minutes, we're going to switch over to between mode. So I'm going to click here and it's going to turn light gray, and that means we're in between mode. I also like to click this button to the right called 68, 95, 99.7 ticks, and that gives me the same tick marks that I created in the previous video on my paper when I drew out the normal distribution. So now I can type in the values of interest. On the left side of the equation go the values that correspond to the driving times, and then I press compute and the probability or area under the curve will show up in the box to the right of the equal sign, and the corresponding shaded area under the curve is here in red. So approximately 19.74% of driving times are between 52 and 54 minutes. So that was part C. In part D, I've allowed an hour to make the trip. What's the probability I'll make it home in time? So we need to translate this sentence to a probability statement. If I'm allowed an hour to make the trip, that means I'll be okay if I drive the distance in either 60 minutes or a lower amount of time. So I can click over to standard mode, and I'm going to indicate the probability that x is less than or equal to 60, and press compute, and that gives me the probability of arriving within 60 minutes. So that's 0.9599. There's approximately 96% chance I'll arrive within an hour. Part E, what are the middle 85% of driving times? Round to the nearest hundredth of a minute. So to get the middle 85% of driving times, I go back to between mode, and 85% represents a probability or area under the curve. So that's going to go in the right box, and you always type a decimal between 0 and 1 in the right box. So I convert that 85% to 0.85, and I leave the two boxes here blank, and I press compute, and StatCrunch is going to know that I want a middle area of 85%, and so it tells me that approximately 85% of driving times are between 47.24 minutes and 58.76 minutes. Part F, how much time should I plan for the trip, to have a 99% probability of arriving within enough time? What's another name for this time, and what's the interpretation? So going back to standard mode, if I want to determine what time to allow for 99% probability, I would go over here and type the decimal equivalent of 99% in the right box and leave this box blank on the left. Press compute. I get 62.31 minutes, which means I have a 99% probability of arriving within 62.31 minutes. And this is also known as the 99th percentile. And so you can interpret this, I'll type it here in the PowerPoint. 99% of driving times are less than 62.31 minutes. And that was the interpretation of 99th percentile.